Today we're going to look at combinations and probability. Our objectives are to be able to find the number of ways an event can occur using combinations and the combination feature on the calculator, and to be able to find the probability an event will occur using combinations. So what is a combination? It's just an arrangement of objects in which order does not matter. We've already talked about permutations where order matters. This is just the same similar thing, basically, except that order does not matter. And we're going to go through some examples of that. So if we compare combinations and permutations, permutations is when order matters, combinations when order does not. So for example, a combination would be in how many ways can you make a group of 3 students if there are 10 students in class. So what I think about is picking 3 students out of this class. Okay? Pick student A, B, and C. So if I have students A, B, and C, would it make a difference if I picked A first, then B, then C? Or what if I say, you know what, I don't want group A, B, C, I want group B, A, C. Does that make a difference? Are those a different group of people? And the answer is no. So since order does not matter, that's a combination. But what happens if I ask, in how many ways can you elect a president, vice president, and secretary? Let's say person A is the president. Okay. Person B ends up being the vice president, and person C ends up being the secretary. And it's like, oh, okay, no, I don't like that. Let's have person B be the president, person A be the vice president, and C be the secretary. Is that the same thing? And the answer is no. Because order matters, that's a permutation. And again, here's another one. In how many different ways can you be dealt 5 cards from a standard deck of cards? So say someone hands you 5 cards. Okay, pretend like what they are. If they take these cards back and then give them back to you in a different order, okay, it doesn't matter what order it is, did that change your hand? No, it's still the same hand that was dealt to you, doesn't matter the order. Then again, it's a combination. And how many different ways can you arrange 5 kids in a line? So we have kid A, B, C, D, and E in line, and kid E jumps to the front. Is that a different order of students in a line? Yes. We would look at these as 2 different things, therefore order matters, making it a permutation. So we have a different notation and formula compared to some of the stuff we did with permutations. Sometimes it looks like this, where you have parentheses and you have n over r. We typically use this where it's NC for combination, R, and what the calculator is going to do is actually a whole bunch of stuff with factorials. Now, how do we read this? It says choosing R elements from a set, that should say set, that has n elements is called forming a combination of n elements taken R at a time. So what this means is we have this many total elements, so say 10 kids in class, and this is how many we want to choose. We want to choose, say, 3 of them to make a group. Or we would say 10, choose 3 if we did it that way. This one could also be written as 10 over 3. And what the calculator does, it does 10 factorial divided by 7 factorial times 3 factorial. I'm not going to go through why this works or where this comes from. We're just going to use the calculator feature to help solve these. And this is kind of the notation we're going to use again to make it easier, because this is what you'll see with the calculator. So we're going to go through 8 different examples, and they go pretty quick because we're just going to use the calculator. Joe's Pizza offers sausage, pepperoni, green peppers, onions, mushrooms, olives, and extra cheese as their toppings. If you have a coupon for a large 3-topping pizza that you want to use, and how many different ways can you order your pizza, assuming you choose 3 different toppings? And that does make a difference, so this actually makes it easier. So we have 3 different toppings. So let's assume we call Joe's Pizza, and I say, you know what, I want sausage, green pepper, and onions. And he takes the order, and I was like, oh, wait, nope, that's not what I want. I want onions, sausage, and green peppers. He'd probably think you were crazy, because that's the exact same pizza you just talked about. And because I was able to switch the order of the same items and it didn't change the outcome, that's why it's a combination. So how many total toppings do I have to choose from? Well, if I count 1, 2, 3, 4, 5, 6, and 7, if I count the cheese, there are 7 total toppings. I want to choose 3 of them to be on my pizza. So what that's going to look like in our calculator, okay, so what I'm going to do, get this to turn on, and I'm going to type in the number 7 for the number of total toppings I have. I'm going to hit the math button and go over to probability, PRB, and And if I go down to option number 3, that's my N choose R. So I have 7 items. I want to choose 3 of them to be on our pizza, so we get an answer of 35. So there are 35 different pizzas that I can order where no 2 are the same. Okay. Our next example says, in how many ways can a committee be formed of 4 girls and 3 boys if you could choose from 10 girls and 7 boys? So again, we just want to match things up. I have 10 girls, but we want to choose 4 of them to be in this committee. And again, the reason why order doesn't matter is because if I have a group of people and I pick 4 girls and 3 boys, it doesn't matter what order I pick them. So say, imagine picking 4 girls and 3 boys, putting them all back and picking the same 4 girls and 3 boys in a different order. It doesn't change the problem. So I have 10 total girls. I want to choose 4 of them to be in the group. And this word and is going to be multiplication. I need this to happen, and I need there to be 7 boys, and I want to choose 3 of them. Well, I already know what 7 choose 3 is. That's 35. Okay, so I'm not going to worry about typing that in again, so that's 35. If I take 10, choose 4, I get 210. So this is 210 times 35, and that gives me a final answer of 7,350 different ways that out of this class of 17 kids that I can choose 4 girls and 3 boys. Okay. Alright, if you flip 8 coins, and how many ways can you get exactly 5 tails? So let's think about this. If I flip a coin 8 times, I could get a head first, then a tail, then another tail, then a head. Let's say another head, another head. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. I think I need one more to be a tail. So 1, 2, 3, 4, 5, 6, 7, 8. So let's pretend, get rid of that, that I flip tails, 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 head, 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 tails, tails. Okay. Now, if it just says I want exactly 5 tails, the order doesn't matter. It could be this order. It could have been heads, 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 and then the 5 tails flipped. So it doesn't matter which one, but what I have here is 8 total positions, 8 total coins that I'm going to flip. And I want to choose 5 of those flips to be tails. So I have 8, choose 5. So again, 8 options, 8 coins. I want to choose 5 of them to be tails, and I get an answer of 56. In example 4, it says, in how many ways can you form a quadrilateral from 12 points if none of the points are collinear? And this, if you remember from geometry, non-collinear means points that aren't all in the same line. So if I draw 12 points that aren't all in the same line, it would look something like a clock, or that's an easier way to do it. Okay, so I have my 12 points, and I need to form a quadrilateral. So what that means is, to get a quadrilateral, I'm going to need to choose 4 points. Okay, so pick any 4 points. If I connect them, that would give me my quadrilateral. Now, did it matter what order I picked them? Well, if I pick this point first, then this one, and then finally that one, I would still get the same quadrilateral. So how many total points do I have? The answer is 12, and I want to choose 1, 2, 3, 4 of them to be part of my quadrilateral. So to save a little bit of time, I'm just going to write that out, and you can type that in your calculator to get your answer. So now let's go to one that's going to talk about probability a little bit more. Okay, remember, probability is the number of ways of what we want over the total number of possible outcomes. So this says a store has 40 DVD players, and they sold 6 of them today. If 8 of the players sent to the store were defective, then what is the probability that 4 of the players sold that day were defective? So this seems a lot more complicated, but I always set these up the same way, and I think it makes it really easy to do the problem. So, just like probability, the total will go on the bottom. So let's think about what totals we have. We have a total of 40 DVDs, or DVD players. And we have 6 of them total were sold. Now it says 8 of the players sent to the store were defective. So out of these 40, I'm going to say 8 were bad, which means 32 were good. And it's always good to account for everything you have. And it says, what is the probability that 4 of the players sold were defective? So I did bad to the left. I want to know what's the probability that 4 of these are bad, which means only 2 of them are good. So if I set it up this way, it's really easy to get my answer. In the numerator, remember, just like the boys and girls, we're going to combine the same groups. I have 8 total that are bad sent to the store, but I only want to choose 4 of them to be sold. Again, this is not what I want, but we just want to know what the probability that this happens. And if I had 4 bad sold, I had to have the 2 good sold. Well, there's 32 total that are good, and I want to choose 2 of them to be sold. But when we deal with probability, the total goes on the bottom. I have 40 DVD players. We're choosing 6 of them to be sold. Again, the reason why this is a combination problem is because if I sell 6 DVD players to people, and then I collect them all back and I sell the same 6 to the same 6 people, but in a different order, it didn't change. I still sold the same DVD players to the same people. So let's look at how you would actually type this in. Okay, so if I clear this out, I have 8, choose 4, okay, times 32, choose 2. Okay, so that gives me that large number. So we have 34,720 in the numerator. I have 40, choose 6 in the denominator. So I have 3838380. So 3 million. There's 3,838,380 different ways to sell 6 DVD players if I only have 40, which is kind of amazing. And again, we could always take this number, 34,720, and divide it by my answer. And that gives me the probability this happens. So this is approximately 0.009. So that's less than 1% chance that I would sell 4 bad ones that day. Okay, so let's look at our 6th example. It says you have 14 CDs at home and you're going on a road trip and you can only fit 5 in your backpack. How many different ways can you bring 5 CDs on your trip? Again, if I have 14 CDs and I choose 5 of them, I put those 5 back and I grab the same 5 in a different order. Did it change anything? The answer is no, so that's why it's a combination problem. So I have 14, choose 5. Again, just since we have this up, 14, choose 5. I need to get faster at typing in. There are actually 2,002 different ways that I can do that. Alright, so let's move on to number 7. It says you have purchased 2 tickets for a school function. Out of the 40 tickets sold, what is the probability that one of your tickets is chosen out of the 5 tickets picked at random? So now we're back to this probability. Okay, so again, let's think about our totals. Again, it just so happens that we have 40 tickets. That's our total number of tickets. And it says you have purchased 2 of these tickets. So I know 2 are mine, which means that 38 belong to other people. Let's write others. It says, what is the probability that one of your tickets is chosen out of the 5 tickets picked? So we have a total of 5 tickets that were picked. And we want to know what is the probability that one of them is mine, meaning that 4 of them belong to other people. Okay? So, again, let's just practice writing this out. My total is in the denominator. I have a total of 40 tickets. We're going to pick a total of 5. And again, here, order doesn't matter. Okay, order doesn't matter for this because if I have 40 tickets and I pick 5 people, if I put them back and pick the tickets in a different order, I still have the same 5 people. We're not talking about winning different prizes. So, in the numerator, I have 2 tickets that are mine. I want to choose one of them to be mine. Again, the mine and mine match up. And then there are 38 other people's tickets, and I want to choose 4 of them to be picked. And again, you can type that in your calculator to figure out the decimal answer. Our last ones deal with cards. It says 4 cards are randomly selected from a standard deck of 52 cards. And I'm not dealing with a normal 5 card draw, just 4 cards. Find the following. Now, when it's written like this, again, this is our notation for probability. So all of mine are going to be fraction answers. So what is the probability that if I select 4 cards out of 52, so those are my totals. So I have 52 total cards and I want to choose 4 of them. So I know that's going to be my denominator for all of these A, B, C, and D options. So I have 2 aces and 2 kings. So this is what I want. So this is what I want to choose, but I need to know the total. So I need to know how many total aces are there in a deck. Well, there are 4, but I only want to choose 2 of them. and I want to choose 2 kings. Well, there are 4 kings in the deck, and I want to choose 2 of them. So this is what I would write out to get my answer. And again, you could type it in. I'm just going to show you the work right now. The next one says, what's the probability that we have all hearts? Well, there are 13 total hearts in a deck. But again, how many cards do I want to choose? That's where we go back to here. I want all of them to be hearts, so I want to choose 4. So again, if you look here, I'm choosing 2 and 2, and my goal is to get a total of 4. I want to get a total of 4, and I want to choose all 4 of them from the heart category. So now it says, what's the probability that I have 2 diamonds and 2 spades? Well, there are 13 diamonds in the deck, and I want to choose 2 of them. And there are 13 spades in the deck, and I want to choose 2 of them. And again, these don't always have to be the same identical things, just depends on what it's going to come out to be. And again, there were 52 total cards, and I want to choose 4 of them from the deck. Alright, this says, what's the probability that I get a 4 of a kind? Now, what does that mean? A 4 of a kind means that all 4 cards are the same value. So there are a couple things about a deck of cards. There's color, red and black. There's suit, which we have hearts. Okay, we have diamonds. Those are the 2 red ones. We have, let's see if I can draw this, spades. And we have clubs. Okay, those are the 4 suits. These are the black suits, the red suits. So if I get a 4 of a kind, for example, I'm going to have, say, the 9 of hearts, 9 of diamonds, 9 of spades, and 9 of clubs. So I'm not really choosing the suit because I want to guarantee I have 1 of each. What I'm choosing is, what is the value? So there's 4 of every type of card in the deck, but how many different types of cards are there? Well, there's ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. So there are actually 13 types of cards, and I want to choose 1 of them to be my 4 of a kind. So this is going to give me the value of the card. That's really all we need, but if it makes you feel better, I'm going to first check and pick the value of the card. And I'm going to talk about the suit, and this will lead into harder problems that we're going to deal with cards. But now I know there's 13 types of cards, ace through king, and I'm going to choose 1 of them. I happen to choose the 9. Once I pick the 9, I need to know how many of those 9s do I want. Well, there are 4 9s in the deck. I want to choose all 4 of them. And this gives me the suits of those cards. And again, I have 52, choose 4. Okay. Now, these are special. Anytime you have 4, choose 4, or if you have 4, choose 4, or 13, choose 13, 10, choose 10, that's always going to be equivalent to 1. So that's why we don't really have to have this, because if you have 4 things and you choose all 4, there's only one way to do that. So this is not needed, but it might be useful to kind of think of it this way. We pick the value and pick the suit, and that's what we would type in. I hope you feel a little bit better about combinations of probability, both using it on the calculator and being able to find the probability of events with combinations.